So hello everyone. Let's start our today's introduction lab for multisim. As you see, I am using version of 10.1.1, so it's not the newest one, but of course if you are using a bit older or newer version of this program, the lab will be pretty the same in belief. Okay, so first of all, let's talk about where you can get it. So the site is ni.com multisim. Let's go to it. ni.com/multisim. Okay. So let's see here. Okay. So you can download it and also yes. So you can download and trial of it. So of course, if you are, and the newest version, as far as I remember, is number 13. So okay, let's start. So we have two tabs which will be the most important for us. First one is simulate analysis and instruments. So we can see a lot of instruments here. For example, oscilloscope, multimeter, wattmeter, and so on. So word generator, logic analyzer, and logic converter we will use, and also this place component. So here we will select our all needed components. So first of all, let's start with the simplest lab. So here we'll try to measure the current and voltage. So first of all, we need source. Yes. So okay. So that's not what we needed. Yeah. So signal voltage. Yes. AC voltage. We will need also ground. So without ground, so by the way, ground is a mandatory component to be used in multisim. Without ground, no circuits could be simulated. Okay, and let's select the basic resistor. Okay, and also indicator. Let's use ampermeter and voltmeter. Yes. Okay. Okay. So as you know, ampermeter should be connected in series to measure the current. So this should be known from physics. Okay, so ground and voltmeter is connected in parallel. Okay, so let's do that. Okay. So here we can set some parameters. So voltage, peak voltage, that means actually amplitude. Okay, so let's set it to 100 volts. So here we can set the internal resistance. So it is very small. So just for yourself, please answer the question why the internal resistance of ampermeter should be as low as possible. Yes. So if you don't know the answer, please check it using internet, or just ask your question by email, or we will discuss it during our next lecture. Okay, so the internal, but in opposite, the internal resistance of voltmeter should be as much as possible. Yes. AC mode. Yes, exactly. As we have AC power, so we should use AC mode. Okay, so now the first circuit is ready and it could be simulated. So let's do it. Okay. So as you see, the current is in amperes 0.071, and voltage is 70.71. So as you know, amplitude is 100 volt. So using Ohm law, you can easily check if it is a correct result or not. But please remember that we are talking about AC, not DC. So by the way, if we are talking about AC, and we have 100 volts and resistance 1 kilo ohm, so why do we have 70? That's a question, because if we would talk about DC, okay, we are talking about DC frequency. I'm not sure if you can do that. Yeah, so if we are talking about DC, okay. Oh no, it can't be used. Okay, so if we are talking about DC, sources, signal voltage, we are talking about DC, the voltage and current will be will be different. So let's have here 100 volts as we had in AC, and let's simulate it. Yes, now you see the current is 0.1 and voltage is minus 100 volts. So the first question is why do we have minus voltage? That's your first question you should answer. And now I'll take the same components. Okay, same component, so I'm just copy pasting that just for our convenience. So we'll launch two circuits. One will be AC and one will be DC. So 100 volts. Okay, so here we have AC and here we have AC as well. Okay. Okay, in parallel. Okay, so let's go. Okay, so what's the difference? So first of all, this is the difference. So the voltage, the peak voltage or amplitude for AC is the same as the voltage in DC case, but current, as you see, is different, and also voltage differs. meter is the same. So the first question is, please try to answer it. The first question is why current and voltage differs. So actually the first one, if we are using Ohm law, you can see that the voltage and current is as it should be. But what about here, the case? Why do we have only 70% about what we have in DC case? And the second question I would also like you to answer is about this negative voltage. Why do we have negative voltage here? Okay, and now let's also use, we should stop it, oscilloscope. So as you know, oscilloscope allows us to see the signal as it is. Okay, here we have, we have two channel oscilloscope. Yeah, let's go. Okay, now, okay, so channel A, it's DC. Yes, that's correct. Channel B should be AC. Okay, so scale, channel. Okay, here we have also, yes, something like that. Yes. Okay. Okay, let's pause it. And now look in detail what we have here. So yes, so let's exclude channel A for now. So as you see, we have only one channel now active. It's channel B, that is the channel connected to AC. Yes. Okay, let's see. Okay, and that's okay. So as you see, the peak voltage here is about 100 volts as we have here. And now let's here, and let's enable here, and let's go. Yes, as you see now, channel A, let's pause it. Channel A amplitude is 100 volt and it's constant. So actually that's the easiest case, but by that we can use it. And so actually these labs tell you how to use this measuring equipment, oscilloscope, and so on. So just for you, please try to use it. Try to use this lab as an introduction lab. So please recreate this lab and please send it to my email. Just some screenshots maybe, and also answers to the question. So as a reminder, the first one, why current and voltage differs if we have the same source of voltage with the same peak value, but we have two cases, DC and AC, the first question. And the second one, why in the case of DC here we have negative voltage. Okay, so actually that's the first lab is over now. Thank you for watching. If you have any questions, so please email them to me. You have my email. So thank you and see you. Bye bye.